So today we're going to get into lesson 5.1, which is over solving systems of linear equations by graphing. So linear equations, systems of linear equations, seem to throw students off, but seem to be something that students struggle with a lot. So definitely make sure you're paying attention as we go through this. We're going to go over a few different ways that you can solve systems of equations. We've obviously talked about linear equations already. Now we're going to get into what is called systems of linear equations. So obviously we need to know what systems of linear equations are. So that's what this is going to show us. This definition says systems of linear equations is a set of two or more linear equations with the same variables. It says two or more, but in 8th grade you're mostly just going to deal with two linear equations at the same time. So basically, we're taking linear equations we've worked with already and doing two at the same time, and you'll see what that looks like. But there's going to be no, at least in 5.1, there's going to be no new methods that we use. We're going to graph these the same way we've always graphed, with the y-intercept and using slope to make our lines. We're just going to be having more than one at a time. So, this is going to tell you what your solution of the linear equation is. It says the solution of a system of linear equations is the ordered pair where the two lines intersect, key word right here, intersect, when they are graphed on a coordinate plane. So, what that's saying is, you're going to graph two different linear equations. You'll do your rise over run, do your y-intercept, that type of stuff, make your first line. And then you'll do the same thing and make a second line. Wherever those lines, there's only going to be one point that those lines intersect at. And whatever that point says, what that ordered pair, where they intersect, is what your solution or what your answer is. And what that means is that's the only ordered pair that you can plug in for both linear equations and make it true. So we're trying to find the solution to these systems of linear equations, and this is how you do it in this first section. You're going to graph them, and the way after you graph them, the one point that they intersect at is your answer. So let's go ahead and look at an example. So make sure you write this down. I'm going to move the camera over to the coordinate plane. So we have solve the system by graphing y equals 2x plus 5 and y equals negative 4x minus 1. So let's go ahead and move this over to the coordinate plane. So again, you should have that written down on yours. The first one, y equals 2x plus 5. So I'm going to write these over here. Y equals 2x plus 5. So remember, first you have to check, is this in slope-intercept form? Slope-intercept form is y equals mx plus b. And this is in that form, so we're good there. So if it's in that form, you can go ahead and start graphing it. So to graph this, remember, first point comes from your y-intercept, which is your b. My b in this problem is 5. So if my b is positive 5, on the y-axis, since that's my y-intercept, I go up to 5, and that's where my first point is going to be, on the line, on the y-axis at 5. So from there, after I make my first point, I can use my slope to get another point. My slope is 2, and remember, we need slope in rise over run form. So if we have a slope of 2, to make that a fraction, we just put a 1 underneath it. So that means my rise is 2 over my run, which is 1. So that means from the point I just made, I'm going to rise 2, 1, 2, and run 1 to the right, since it's positive, that's right. And that's where I make another point. And I can repeat that. 1, 2, right 1, like that. So that is where I'll make my first line. And like I talked about before, you want to extend this because there's going to be some point where this intersects my other line whenever I draw it. So It'll look like that. So there's my first line. So that's my first line. Let me get another marker or a different color so just so that we can see these different lines. My next one. So you graph the first one, then you graph the second one on the same graph or on the same coordinate plane. So we have y equals negative 4x minus 1. So again, your first point is made from your y-intercept. So y-intercept in this case is negative 1. That minus 1 means this is negative 1. So I go down on my y-axis to negative 1, and that's where my first point will be, on negative 1. And then from there, I use my slope to get another point. My slope is negative 4. Since that is a whole number, I can put it over 1 to make it a fraction because I need it in rise over run form. So my rise is negative 4. So that means from this point, remember your first movement should be up or down. Since it's negative, that should tell me I need to go down 4. 1, 2, 3, 4. And then my bottom number is 1, so I go right 1, like that. So there is my second point. So then I can draw my line through those. Again, you want to extend it. So my other line should look something like that. So once you graph both lines, and I know that pink's hard to see. Let me see if the red will show up a little better. So again, I've got a point right here. The red's not going to be much better, but maybe a little bit. And then there's my line. So again, this is my line. After you've graphed both lines, you're looking for what that one point is that they intersect at. So if I look, right here is where my black line and my red pink line go through one another. They intersect. So that is, get a new color just to show this. This right here is my intersection point. So since they intersect right there, that is my answer. So the ordered pair that's my answer is negative 1, 3. So your answer is negative 1, 3. So that's your final answer. All that means is you can plug these numbers in for this equation and for this equation for x and y, and it will make both of them true. Okay, so you're looking for the solution that makes both lines true. So where they intersect is your answer. So that's how we solve systems of equations by graphing. So let me pull up another one and I'll write it for you. So this one I want you to try on your own. The points are, and I'm going to stay here just so I don't have to keep moving back and forth, but the points on this example I want you to try are y equals x minus 1 and y equals negative x plus 3. So again, pause the video, try that on your own. When you come back, let's talk about how we are going to work through this problem. So, my first one, y equals x minus 1. That's in slope-intercept form, so once it's in slope-intercept form, I'm just going to start graphing by using my y-intercept first. So remember, b is my y-intercept. So in this one, negative 1 is my y-intercept. So I go on the y-axis, down to negative 1, make a point. There's your first point. From there, I have to use my slope, but some students will say, well, there's no slope because there's no number here. But remember, if there's no number in front of x, that invisible number is 1. So my slope is 1, so if I have a slope of 1, I can make that a fraction by putting it over 1. So my rise over run is 1 over 1. So that means from this point, I'm going to go up 1, right 1. There's another point. Up 1, right 1, and I can keep doing that. But that's what my first line will look like for y equals x minus 1. So it should look like this whenever I graph it. Okay, so it should look something like that when you graph that. So there's your first line. So then from there, you need to use the second point, or the second line, which is y, let me write this in the other color. Y equals negative x plus 3. So y equals negative x plus 3. First point comes from your y-intercept. My y-intercept here is positive 3. So I go up to positive 3 on the y-axis, make a point. My slope, again, there's no number in front, but since there's no number, that means there's an invisible 1. And here, there's a minus x, so that means it's a negative 1. Negative 1 is my slope, and I put that over 1 to make it rise over run. So what that means is my top number is negative 1. So that means the first movement from the point I just made is down 1, and then positive 1 on the bottom tells me go right 1. So then I'll connect those. So there's my second line. So you should be able to easily see your intersection point of these two lines is right there. That is my intersection point. So my answer for this one is 2, 1. The ordered pair 2, 1 is your answer. That's where those two lines intersect one another. Okay, so that's how we solve by systems of equations. So make sure you understand how we are breaking that down. All you're doing is the same thing we've done in the past, where you're going to solve, make sure they're in slope-intercept form, and then you're going to graph each one individually, and you're just looking where those intersect each other. Okay, so I'm going to move back over just for another thing we need to talk about, just to make sure we can do the more complex ones too. So, we also might have systems of linear equations where they're not in slope-intercept form. So all this is saying is, remember, if the equations are not in slope-intercept form, be sure to put the equations in this form, then graph. So if you don't have your y by itself, you need to rearrange the equation, get y by itself, and then you can graph it from there. So let's look at an example of that. So this one we have solve the system by graphing. X minus y equals 5. Negative 3x plus y equals negative 1. So first thing you need to do is you realize this is not in slope-intercept form. So if it's not in slope-intercept form, you need to rearrange it to get to slope-intercept form. So slope-intercept form means your y is by itself. So first, if I'm doing this problem, I need to move my x first. Positive x means I subtract x from both sides. Cancels, cancels. What's left is negative y. Make sure you don't make the mistake of just bringing down y. This negative sign goes with it. Equals, remember in slope-intercept form we want that x first. So I'm going to put negative x plus 5, because it's a positive 5. And you can't combine these two together because they're not like terms. This one doesn't have a variable, this one does. So this is where we're at so far. Lastly, we have negative y, which is technically negative 1y. So negative 1 is being multiplied by y. So in order to move negative 1, we do the opposite, which is divide by negative 1. That'll cancel the negative 1s, leaving you with y, which is what you needed. And then remember, if you're dividing this whole side by negative 1, you're dividing each individual term by negative 1. So negative x divided by negative 1 is just positive x. Because a negative divided by a negative is a positive. Positive 5 divided by negative 1 is negative 5, or minus 5. So now we have slope-intercept form. That's the first one we can graph. So then let's look at the second one. We have negative 3x plus y equals negative 1. Okay, so here we just again look and say this is not in slope-intercept form. We need the y by itself. So to get the y by itself, the negative 3x has to move. So minus 3x, the opposite of minus 3x, if I'm moving the whole thing, is to add 3x to both sides. The negative 3x, positive 3x cancel. Bring down my positive y equals the negative 1 and the positive 3x cannot combine because they're not like terms. This has an x, this does not. Again, we need the x in front in y equals mx plus b. So I'm going to write the 3x first and then my minus 1. So now that is in slope-intercept form. So once I have them both the slope-intercept form, I can go ahead and graph it on my coordinate plane. So make sure you write these two down because this is what we're going to graph now on the coordinate plane. So, our two equations were y equals x minus 5 and y equals 3x minus 1. Okay, so once we have this, we just graph each one individually. So let me actually rewrite this one with the blue so we have two different colors. Okay, so once we're here, I'm going to go ahead and graph this first one. Y equals x minus 5. First point comes from your y-intercept. My y-intercept is negative 5. So go down to negative 5 on the y-axis, make a point. I know I'm going quickly through graphing, but hopefully we have this down by now. We've covered graphing linear equations a lot. So remember, your first point comes from your y-intercept, and then your second point, use your slope, rise over run, to get that second point. So there's my first point. My slope, if there's no number with the x, my slope is 1. There's an invisible 1. So I change that to 1 over 1 for rise over run. So 1 over 1 would be up 1, right 1. And I can keep doing that, up 1, right 1. And that's how I'm going to make, those are the points I'll use to make my line. So when I extend my line, it should look something like that. Okay, so there's my line for that first equation. So then I use my second equation, y equals 3x minus 1. So again, my first point comes from my y-intercept, which is negative 1. So I go down to negative 1, make a point. Then I use my slope, which is 3. To make that in rise over run form, I put it 3 over 1. So from here, I go up 3. That's my rise. 1, 2, 3. Run 1. And there's my second point. Okay, so when I draw my line through those points, should come up with something that looks like that. So this one, you can see these two lines intersect. This is where the two lines intersect. So that's what you're looking for. Whenever you're graphing linear equations, systems of linear equations, you're looking for where they intersect one another. And there's the point they intersect. So your solution would be -2, -7. That is your solution. So again, what that means is if I plug -2 in for x on both of these and -7 in for y, when you solve it, both of them, both sides will match on both equations, meaning they're both true. So that's how you solve systems of equations by graphing. So hopefully you understood how we did that. Like I said, there's no new concepts because all we're doing is things we've done in the past, which is graphing linear equations by using our y-intercept and then our slope. But now we're just doing more than one on the same graph, and we just have to look and find that point that they intersect at. Hope that helps. Thanks.